So this is the third and final video of our water and carbon cycles topic. This one will focus on the Amazon rainforest as our case study for carbon. It does overlap with the water cycle as well, however, as an international example. So it can be used in a number of different ways. The only thing that hasn't been covered by these videos is desertification. Now this is an impact of a changing carbon budget on the land. It is stretch and challenge. There's a video about elephants and Senegal's Great Green Wall, and that's a summary of it there, but it's a stretch and challenge one. So let's crack on with the rainforests then. Now, the tropical rainforest has loads of facts to do with carbon and to do with water. Basically, the Amazon has a lot of carbon in it. It has 300 billion trees, that's 15,000 different species, and they reckon that it stores 20% of the world's carbon in terms of biomass, in terms of the biosphere. So there were lots of thoughts of how this would change with climate. We did think that would increase in temperatures would stimulate plant growth, and that would then store more carbon. Because the levels of the forest have been increasing in terms of how much carbon they do store per year. However, research does show that we think that actually it's losing its capacity to store carbon from the atmosphere. Net uptake has halved and is overtaken by fossil fuels just from Latin America alone. Still though, it is a big source of storing carbon. It is thought that there are approximately 100 PGC, that's the equivalent of a gigaton. It's another way of writing gigaton. Petrogram of carbon or something it stands for in Amazonia. In terms of its actual area, it's huge, and this goes for the river and for the actual rainforest itself. It's 5.3 million kilometres squared, and it holds 17% of all of our land vegetation carbon stock. This person, Fawcett, showed that 1% of all the tree species in the Amazon account for half of the carbon locked in South American rainforest. Just 1%, okay? So there's a huge amount there. Now, this one says 16,000 tree species, his one does. Textbook says 15,000, so, you know, they don't know. They haven't counted them all yet. Untouched Amazon forests take in more carbon dioxide than they put back into the atmosphere, okay? Estimated to store 80 to 120 billion tonnes of carbon, therefore it's a sink. Because, you know, they respire at night, but they are taking in more, storing more than they give out, so it's carbon at sink. That is changing over time though. Dead Amazonian trees emit 1.9 billion tonnes in a normal year. However, it absorbs 2.2, so it's a sink of about 0.3 billion tonnes of carbon where it's untouched. But this is decreasing with time. It's becoming less efficient at trapping carbon, and there's a number of reasons for that, but we do think that it's not the positive feedback loop that climate change is having a negative impact on growth in the Amazon. In terms of the water cycle then, the actual river, the Amazon River that flows through this rainforest, it reaches, its mouth is in the Atlantic Ocean. Its source is up in the Andes. The drainage area, the drainage basin, is absolutely huge, and the river is huge as well. The discharge from this, it's somewhere between a fifth and a sixth of the total discharge that reaches the oceans from everywhere in the world is from the Amazon. So that's how big it is in terms of the volume of water that passes through it. Even one of its tributaries, the Rio Negro, is the second largest river in the world in terms of its discharge. It's 100 metres deep and 14 kilometres wide, that tributary. So, other facts then. Its input, its precipitation, 2,300 millimetres annually. Oh, that's meant to say 6,000. In the northwest, it can exceed and reach 6,000 millimetres up in the northwest region, up near the Andes there. Now, only a third of that water actually reaches the Atlantic Ocean. A lot of it's stored, a lot of it is just recycled straight from the canopy where it's been intercepted up to form clouds and rains back down again. So there's a lot of recycling going on. There's more evaporation that sort of helps that from other surfaces, and they form the rain clouds 50 to 80% of moisture remains in the water cycle. It's recycled. It's a huge efficiency, and that's why deforesting has huge impacts on precipitation. So that does have global effects. The moisture created by this rainforest does travel around the world as these clouds. Affects rainfall patterns in Europe and China as far away as that as well. So when they're cut down, less moisture goes into the atmosphere and rainfall does decline in the area, but also changes rainfall patterns around the world as well. So we'll come on to what happens when we do change this ecosystem in just a little bit. But let's have a little look now at the sort of physical characteristics, the soils, the geology, the climate, the vegetation, and the relief in the Amazon, okay? It's warm and wet all year around. We've already mentioned how much it rains. Temperature is not as hot as might be expected. It rarely gets higher than 33 degrees, but it's fairly constant, so it doesn't drop much below 22 as well. It does have this convectional rainfall, thunderstorms, most days, and that's because it's very humid as well. There is some regional variation in precipitation. The precipitation doubles the precipitation of the Manaus region because of what's getting in one area moving downwards as well. So the geology, we have sedimentary rocks, 13,000 feet thick. That's in the upper areas near the Andes. In the actual centre of the Amazon, there's very few rocks. We're talking about digging down to get to the rocks. And that's because in the Amazon River they've been eroded down, and it's mostly soft sedimentary clay because of the massive amount of flooding that takes place because of the river and its tributaries as well. Right, so we've got that's impermeable closer to the river and then permeable further away. The relief then very steep. The highest point of the watershed is over 6,500 metres. Vegetation grows really rapidly. We've got a very efficient nutrient cycle. There's no winter and autumn, so the leaves are just being shed all the time, which means the nutrients go straight back into the soil and then absorbed by the trees or washed away by the rainfall. That's called leaching, which leads me into the soils. They're very deep, but they're nutrient poor. Only the top 50 metres has many nutrients at all. So the vegetation has very wide roots, one for stability, but also because that's where they need to absorb these nutrients from the top layer of the soil. Now you did that in population and the environment, so there should be some overlaps with your knowledge there. So, how do we affect these? What are the changes that are going on? So let's have a look at consequences of change in the Amazon. Let's look at water, and then let's look at sort of the carbon elements of this. So when we're deforesting, rivers are affected. That's going to increase soil erosion, so it's going to change, the amount of soil in that water. It's going to affect the amount of interception, flash floods, and then we're going to have the actual normal water cycling that takes place. Is going to be droughts in the area that can lead to the risk of wildfire in a tropical rainforest, which sounds obscene, but it's not getting that recycling of the water. So once you cut it down, it doesn't happen again. And then it could disrupt the water supplies because of that soil and silt that's being washed in. Species are going to be affected, biodiversity, because of the water getting warmer as well. It's going to affect the oxygen concentrations, which could affect the breeding grounds of different animals there. So it's going to affect the species which are used to the damp, wet conditions. They're physically adapted for it as well. 85% of the rainforest will die with a 4 degree C temperature change. We're not sure about 2 degrees C at the moment. We do think it will survive with that. But here is a nice positive feedback loop to do with wildfires and how that happens for you there. So Amazonian soil, it does contain between 4 and 9 kilograms of carbon in the upper 50 centimetres of soil layer. That is per metre squared, okay? When we deforest though, that carbon is lost to the atmosphere because then it can dry out, it decomposes and transfers it to the atmosphere as well. It might also be washed away with the surface runoff that's going to happen. So lots of facts for you to take in there. So what are the drivers of change then? Right. Basically, it's human interaction. Brazilian Amazon was deforested really rapidly between 2000 and 2007. It then decreased between 2013 and 18, and now it's on the increase again. They've got a new president who's kind of like, right, this is our resource, let's go for it. Chop it down, make as much money. Who are you to tell us to protect it? And that's seen an insane number of wildfires and so on starting in the last couple of years. So it's very concerning. Brazil is the worst sort of country for this. Other areas are protecting it more, but Brazil has the most Amazon in it, if that makes sense, at the same time. Brazil alone is the fourth largest climate polluter. They're emitting a lot, and that is partly to do with deforestation and land use change. When they do deforest, it's that slash and burn technique. They cut it down really quickly and then they burn it because that's the fastest way to go about it. And also, if you burn something, it puts nutrients into the soils like volcanoes. So if they're growing crops on it, that's what they want to do. However, that's short term. That soil can't then hold in moisture. There's more evaporation that's going to happen. It's not shaded as much. It's going to increase the albedo and temperature. It's going to absorb more. It's going to be changing it that way as well. And it reduces the porosity of the soil. It's not going to be held together by the roots. You're going to get more soil erosion and so on and so on. Now, any moisture that does evaporate may form, because there's more dust in the air because of the fires, lots of very small water particles that never get big enough to rain. And that's the problem. Then they get blown away and it never rains over the deforested areas. So that's why you don't get so much rainfall. It's not just to do with the lack of recycling, even though the water is being evaporated. It's just not creating the rain clouds like we would expect, just like little fluffy white ones, not the sort of thunderstorm clouds. And that carbon store then, if it is burnt, puts that carbon straight back into the atmosphere. So there's some facts at the bottom. If it's deforested and used for pasture, for cattle, or even small crops, that's some of the differences in what we can see between those two areas. So those are our drivers of change that we've got going on there. There isn't, it's not all bad, okay? We've got some mitigation techniques, okay? Small amount here, but there's a little bit more here. Selective logging, only fell the trees that you're going to make the most of. Replanting them as you're cutting them down. So Peru's quite good for this. They're restoring 3.2 million hectares of forest by last year. They were on target to do that. You need to balance the number of trees you cut down with what you're replanting so that the natural ecosystem and food chains remain intact for that. You can pass laws on it that ban the use of wood from forests that aren't managed sustainably. These can be international ones, so there's not a market for it as well. They can do that nationally though as well. They can control the excessive logging, control the land use, reduce illegal logging as well. Protect them by national parks. That means you might make more money from them. Central Amazon Conservation Complex in Brazil was set up to protect the biodiversity in that area. You're not allowed to do any damaging activities there. So that's a brief rundown of our Amazon case study. Lots of key facts, especially about the numbers, the stores of carbon, the levels of water in there. Lots of frequent facts and figures for you to put into your essays. The one thing, I don't know if I mentioned that before, the interdependence of carbon and water, that was done back in the water revision PowerPoint that we've already gone through. So that's that. Thank you very much.